The Comet Spark, Troubleshooting the Charging Gate. The workshop was filled with the scent of solder and the hum of cooling fans. Arjun sat at his workbench staring at a dead Inventec Comet laptop. It wouldn't turn on, and the charging light remained dark. Professor Harshad Patel, wearing his signature glasses and a professional blazer, walked over with a warm smile. "Don't be intimidated by the silence, Arjun," the professor said. "A motherboard is like a series of locks. To find why it won't wake up, we must find which key is missing at the charging gate. We begin at the very beginning, the adapter voltage." Arjun grabbed his multimeter and touched the probes to the input jack. "I have 19 volts at the input, Professor," he reported. Professor Patel nodded. "That is PVADPTR. The adapter is doing its job, but the board doesn't just take that power blindly. It uses a controller, the BQ24736, also known as U6000. For this chip to work, it must first have its own energy. We need to check pin 20, the VCC." Arjun carefully placed his fine-tipped probe on the tiny pin. 19 volts are present here too, sir." "Now the chip is awake," Professor Patel explained. "But it is a cautious gatekeeper. It wants to make sure the adapter voltage is correct before proceeding. It uses a signal called ACDET on pin 6. He pointed to two small resistors on the board, R6021 and R6023. These form a voltage divider. The BQ chip needs to see a voltage above 2.4 volts here. If it is too low, the chip will refuse to open the gates for the rest of the system. Arjun measured pin 6. "It's 2.6 volts, Professor. Right in the window." Patel clapped his hands gently. "Excellent. Now, watch the internal logic. Once the chip likes the ACDET level, it produces its own internal voltage called REGN on pin 16. This is a 6-volt LDO, a low dropout regulator. It powers the internal circuitry that will eventually drive the power gates. Let us see if the gatekeeper has found its inner strength." Arjun checked pin 16 and confirmed REGN was exactly 6 volts. He was starting to see the logic. Professor Patel moved to the whiteboard. Now comes the heavy lifting. To let the 19 volts flow into the motherboard, the chip must turn on two N-channel MOSFETs, Q6012 and Q6011. But there is a trick. To turn on an N-channel gate when there is 19 volts at the source, we need a higher voltage, about 25 Vi. The chip creates this using a charge pump signal called ACDRV on pin 4. "Check the gate of the first MOSFET," the professor instructed. Arjun touched the probe to Q6012. "It's 25.4 volts. The charge pump is working." Professor Patel beamed. "That means the 19 volts has passed the first two doors. Power is now flowing from PVADPTR to the main power rail, which we call PVPACK. This is the lifeblood that will eventually feed the CPU, the memory, and the battery." "Is the laptop ready to start now?" Arjun asked. "Almost," Patel replied. "The chip has one more handshake to make. It must tell the motherboard's brain, the embedded controller, that everything is safe. It does this via the ACOK signal on pin 5. This pin should be pulled high, usually to 3.3 volts. If ACOK is missing, the brain will never let the system boot, even if the voltage is present everywhere else." Arjun checked pin 5. 3.3 volts. ACOK is there. Just as he said it, a tiny LED on the side of the motherboard flickered to life. Professor Patel nodded. "The handshake is complete. But remember, the BQ24736 does more than just open the gate. It also monitors current through the SRP and SRN pins. These pins measure the voltage drop across a sense resistor to calculate power consumption. It's like a smart meter for the motherboard." "And the battery?" Arjun asked. Patel pointed to the path leading from the main rail. "When you plug in the battery, the chip changes roles. It becomes a charger. It switches the battery MOSFETs to step down that 19 volts to the charging voltage the battery needs. It constantly talks to the battery's internal computer to ensure it doesn't get too hot or charge too fast. It is a guardian that never sleeps. Arjun pressed the power button. The fan on the Inventec Comet began to spin and the screen flashed the logo. "We did it!" Arjun cheered. Professor Patel patted him on the shoulder. "No, Arjun, you did it. You didn't just fix a board. You understood the signals. VCC to wake, ACDET to verify, REGN to prepare, ACDRV to open the gate, and ACOK to signal the brain. That is the language of the motherboard.